Hello everyone, hope you all are doing really well. This is the 8th lecture in the series Multithreading in Java. Till now in this lecture series of multithreading we have learned about the basics like what are the differences between the threads and processes, what are the different ways to create new threads, what are the different methods to make your parent thread wait for the child thread's completion. Then we studied about the race conditions, the critical sections of your code, and how can you make sure that the critical sections are taken care of, that is the access of multiple threads in a mutually exclusive way so that your code performs in the way you want it to perform. In all of these things we have missed one concept, and that I want to share in this particular lecture is how do different threads communicate with each other. So basically inter-thread communication. Now we all know that inter-thread communication is very necessary if you want to design a abstract system or abstract framework around the core thread concepts. Currently Java 8 has been providing some different frameworks on this which is abstracting out the basic core thread concepts, and I will be teaching about the same in the future lectures, but it is always good to know the underlying concepts which are being provided in the underlying technologies, and that's why I wanted to cover this topic of inter-thread communication. Now let us begin. Before beginning, I would like to suggest you that if you want to actually understand the very good core concepts of multithreading, and if you want to understand these things in details, I will also suggest you to go through the book of Mr. Brian Goer's Java Concurrency in Practice. I am also attaching a link of that book in my description box. It is a book which I have studied when I started to program in Java professionally, and it is actually a very good book and it will help you guys. So please, if you want, you can just check out the description box of mine. Now let us begin with this lecture. Now inter-thread communication, to do that there are three methods which are being provided in Java which threads use to communicate with each other. The three methods are namely wait, notify, and NotifyAll. All these three methods are provided in the object class of Java. As we all know that object class is the main parent class in Java, which is being extended, or somehow all the classes in Java somehow are the child classes of object class, that is in the class hierarchy. All of them point to the object class as a parent. Now before going through the exact details of those three methods, we should understand that there is an important concept of lock objects monitor ownership, that is which thread actually owns the lock object. There are different ways in which a thread becomes the owner of the object's monitor. That is, what do you mean by the object's monitor? So basically the object argument which you pass to the synchronized block is called the object, and the monitor is basically the intrinsic monitor on which the lock is taken. So in case of methods, the object is the instance of which the method belongs to, or if you have created an object to use as a lock, then that will be the object. So a thread becomes the owner of the object's monitor one of three ways. Firstly, by executing a synchronized instance method of that object. Basically that if you have an object and you have a method which is marked as synchronized, so whenever a thread is executing that method, it is the owner of the object of that instance, because that instance object is being used as the lock. Or second is by executing the body of a synchronized statement that synchronizes on the object. So if you have created an object, or if you are using this keyword to take a lock on the instance of the object, in both the cases the thread which is executing that synchronized block will be the owner of that corresponding lock object's monitor. And for the type, class, or the static method variables, the thread becomes the owner of the class object's monitor. Now let's study about the wait method. Now what is the wait method and what is its use case? Whenever the wait method is called, the thread which is currently executing the synchronized block, it releases the ownership of the monitor. That is, whatever the lock object on which the lock was taken, the thread releases the ownership of the lock object, so another thread can take the lock on that same object. So whenever the wait method is called, the thread releases ownership of the monitor and waits until another thread notifies threads waiting on this object's monitor to wake up, either through a call to the notify method or the NotifyAll method. So to simply put, whenever you call a wait method, the thread releases the lock object and goes to a wait state. Now if some other thread calls the notify method or the notify all method on the same lock object, so basically some other thread which is actually a owner of the same lock object. We discussed that how can some thread become the owner, by if it is executing the synchronized code block and the synchronization is done on the same lock object. So whenever a thread is in the waiting state, if some other object calls the notify or notify all method, and that thread should be owning the same object monitor, then the threads which are being waiting on that object monitor are again woken up. Now the thread then waits until it can reobtain ownership of the monitor and resume execution. So it can be a case that multiple threads are waiting on the same object's monitor. So whenever they wake up, they wait so that they can again obtain the lock on that same monitor and then they resume execution. Now this method should only be called by a thread that is the owner of this object's monitor. Now there is an important concept behind the entire description of the wait method. So if you feel that this is a bit confusing, don't worry. In the next lecture I will run a demo on each and every of these methods and explain in details in a video demo where I will run different codes and make you understand that what do I mean when I say a lock objects monitor and ownership of the lock object monitor. Just for now, I want you to understand that what these methods are there for doing, and if you have a bit of confusion, it is okay. I will explain them in the next lecture in detail again and with the help of a demo which will be easier to understand. But right now you should just understand the concepts that how these methods are used. Now whenever wait is called on a thread, the thread releases the lock. So in this way a new thread can enter the synchronization block. So you should always remember this, that till now what we studied is that inside a synchronization block only one thread can be at a time. Here, although a thread hasn't completed its entire execution of the code, but a second thread has entered. So even though a code block is synchronized and the first thread which acquired the lock didn't finish the execution of complete synchronized block of code, another thread can enter the synchronized block. How can it happen? That the wait method is called in between the synchronization block of the first thread which acquired the lock, and since that thread after the wait method is called, it releases the lock, and then the second thread can acquire the same lock and enter the synchronization block. This still doesn't mean that concurrent execution is happening. This is very important. You should understand that this still doesn't mean that concurrent execution is happening, because the first thread is already now in a wait state. It is not executing the code block. So at a time only one thread is executing the code inside the synchronized block. Now notify method, by the name itself suggests, notify method is also present in the java.lang.object class. Notify method wakes up a single thread which has been waiting on the lock object's monitor. If many threads are waiting on the lock object's monitor, one of them is selected arbitrarily. And notify all method, as the name suggests, whenever notify all is called on a thread, all the threads waiting on the calling thread's own lock object's monitor wake up. So basically that the notify method will wake up only one thread which is waiting on the lock object's monitor, and the notify all method will wake up all the threads which are being waiting. So but after waking up, you should again understand that after waking up, it is not as such that all the threads will start executing in parallel. Only one of them can acquire the same lock on which they had gone to wait previously. So only one of them will get the lock, and they will that thread will start executing, and all other threads will again wait for their turn to get a lock on that particular object's monitor. So if you like the video, please subscribe my channel and give a thumbs up to the video, and share this video to your friends so that they can also get to know about this content. And thank you.